In this video, we're going to introduce trigonometric identities. So we start with our angle like this. So if theta is in the first quadrant, it's going to be your x, y, and this is r. And so we say sine theta is y over r, cos theta is x over r, tan theta is y over x. Now, by Pythagoras, we have the following. So by Pythagoras, we have x squared plus y squared is equal to r squared. If we divide by r squared, then this is going to be x squared over r squared, y squared over r squared equals r squared over r squared. Then the right hand side here is just 1. This first term you can write as x over r all squared. Second term you can write as y over r all squared. However, y over r is sine theta, so it means we can plug in sine theta squared there. X over r is cosine theta, so we can plug in cosine theta squared there. So notationally we write sine theta all squared like this and cosine theta all squared like that. So this is called the fundamental identity of trigonometry. It says if you take any angle and do the sine, square that, do the cosine, square that, and add the two, you always find the final answer is going to be 1. So let's demonstrate. Suppose we do sine 59, or 56 as well, doesn't matter, squared, okay, plus cosine 56 squared, 56 squared, no, squared, equal, and that gives us 1. You can try any other value. So let's do sine of what's going on there? Do sine of 217 or 214 squared plus cosine of the same thing squared, cosine 214 squared. Okay, so this is always going to be 1, and it's called the fundamental identity of trigonometry. So what we can do is we can use this to prove identities, trigonometric identities. So trigonometric identities are trigonometric formulas that equate two expressions or give the relationship between two trigonometric expressions. We're just going to go through examples. I am going to do 3 examples, and then I'll give you 1, 2 to go through. All right. So suppose we have these trigonometric identities to prove. We're going to do A, B, and C, and then we're going to give you a chance to work through D. Here are some guidelines for trigonometric proving trigonometric identities. First one is to express everything in terms of sines and cosines only. Then the second one is to work from the complicated side. The last one, it got fractions. We're going to combine them into single fractions. So that means our algebra of fractions is going to be pretty necessary here. So the first one we have got want to show that sine squared is equals to 1 plus tangent squared theta. So this time, if we look at these two, the right hand side looks complicated, so that's the side we're going to work from. So tangent theta is sine over cosine theta, so tangent squared theta is going to be sine squared theta over cosine squared theta. In the denominator, going to have 1 plus sine squared theta over cosine squared theta. Then this denominator here, going to write as one fraction. So if you say over 1 here, then the LCM is going to be cosine squared. So sine squared theta over cosine squared theta is just the numerator. Then in the denominator we're going to have cosine squared theta. 1 goes into cosine squared times. Then cosine squared goes into cosine squared once. 1 times sine squared is sine squared. Now remember, sine squared plus cosine squared, or cosine squared plus sine squared, is equals to 1. So that means we can now write this as sine squared theta over cosine squared theta divided by 1 over cosine squared theta. So this can be written as, if you remember your division of fractions, so I'm just going to say divided by 1 over cosine squared, but that is the same as sine squared theta over cosine squared theta times cosine squared theta over 1, and then these are going to cancel out, so ultimately this gives us just sine squared theta. This is now the same as the left hand side, so the proof is complete. In part B, we've got tangent theta plus cotangent theta is equal to secant theta cosecant theta. Remember, just going to rewrite everything in terms of sine and cosine. Tangent theta is sine theta over cosine theta. Cotangent theta is a reciprocal of tangent, so that one is going to be cosine theta over sine theta. The right hand side, secant theta, we said is 1 over cosine theta. cosecant theta is 1 over sine theta. Okay, so that's this identity entirely in terms of sines and cosines. This time this looks complicated, so I'm going to work from this side. So left hand side, the LCM, we've got two fractions, so we're going to write them as one fraction. LCM is sine theta cosine theta. Now cosine is going to go here, sine times, then sine times sine is sine squared, and then sine goes here, cosine times cosine squared. Then again the numerator is just 1 sine theta cosine theta, but if you look at this, it's already the same as that right hand side there, so that means the proof is complete. One more to go. So in C we have 1 over 1 minus sine theta 1 plus sine theta equals to 2 secant squared. The left hand side is already in terms of sines only. This one I'm going to write it. So secant is 1 over cosine, so secant squared is 1 over cosine squared. So this side we can write as cosine squared theta, 2 over cosine squared theta. We're going to work from the left hand side, which is this side here. We've got two fractions again, the LCM going to be 1 minus cosine 1 minus sine theta 1 plus sine theta. 1 minus sine theta is going to go here, 1 plus sine theta times, so 1 plus sine theta there. Then 1 plus sine theta is going to go over here, 1 minus sine theta times. Then this is going to cancel out. 1 plus 1 is 2, so we got 2. So we already have 2 in the numerator, like we're expecting. In the denominator, we got a difference of 2 squares here, so that we can write as 1 minus sine squared theta. Now, since sine squared theta cos plus cos squared theta is 1, we take this to the other side. 1 minus sine squared theta cosine squared theta. So we can take this and plug it in here. So then we're going to have 2 over cosine squared, but that's already the same as the right hand side there, so the proof is complete. Okay, we're going to give you an opportunity now to try the last one, this one here. So just pause the video, have a go at it, and then when you continue the video, right, we're now going to scroll down to our solution of the proof of this identity here. So the first thing we're going to do is to write everything in terms of sine and cosine. So this is already in terms of sine and cosine. Tangent is sine over cosine, cot is cos over sine, secant is 1 over sine, cosecant is 1 over sine. Then we're going to work from this side. So we're going to write this as one fraction, this is what it works out to. Then sine squared plus cosine squared is 1. Then if you multiply these two, so it goes in the numerator, goes in the denominator, then you can use the distributive law of division of fractions. You get sine over this, then cosine over the same thing. Then in the first term the sine is going to cancel out, the second term the cosine is going to cancel out, and we got 1 over cosine plus 1 over sine, and this is already the same as the right hand side.